Hi there, and welcome to this inside look at the Fritz AI end-to-end platform for mobile machine learning. I'm Dr. Jameson Toole, CTO and co-founder of Fritz, where I lead our engineering team. Today, I want to show you how to work with some of the core components of our end-to-end platform, which will help us build a model from scratch and test it on a target mobile device. In this case, we'll be training a pose estimation model that tracks the location of fingertips in live video. The Fritz AI platform is designed to address all stages of a project's ML lifecycle, from initially collecting and labeling data, through monitoring and improving models in production. This lifecycle can be particularly tricky. It has all the complexities of machine learning with all the constraints of mobile. Hopefully, you'll see that our platform simplifies workflows and makes adding ML capabilities to your app easy. Here's the plan of attack. First, we'll generate a dataset using our synthetic data generation tool. We'll label just a few images manually and then programmatically generate thousands more that we can use to train our model. This is a really neat process that allows us to create brand new data sets in a matter of minutes, as opposed to spending weeks of time and lots of money collecting and labeling data ourselves. Second, we'll take that generated dataset and train a model optimized for our use case without writing any code. Third, we'll test that model out in a real mobile app and collect additional training data to improve performance. After creating a Fritz account, you'll be taken to the project overview screen. At the top here, you'll see cards for starting various phases of the ML lifecycle. You can also register your app or check out some of the pre-trained features that we have available. In this case, the first step is going to be generating some data that we can use to train a model. So I'm going to click the Collect and Generate card in the center. This is the Datasets page. Here you can access all of the data used to train and evaluate models. There are a few core concepts to know about. First are collections. Collections are comprised of images and their associated annotations. Collections are mutable, meaning that you can add and remove images over time and continuously improve annotations. Datasets are slightly different. They represent snapshots of image collections frozen in time. Datasets are what we actually use to train models. This way, we always have an exact record of model inputs so that our experiments are auditable and reproducible. Let's make a new image collection. There are three different types of collections that we can choose from. In this case, we want to make a seed image collection. Seed image collections contain a small number of annotated images with transparent backgrounds. These can be used to generate synthetic datasets. You can think of seed images like stickers that will get pasted onto random backgrounds to generate thousands of different images for model training. Let's give our image collection a name. Confirm. And now we see an empty image collection. Let's go ahead and upload some photos. Now, I've already created about 15 seed images to use for this project, but you'll need to find some images with a subject that you want your model to detect, and then use an image editor like Photoshop or Sketch to create a transparent PNG with the background removed. As we can see here, all of the images that are uploaded have an annotation status of incomplete, and that means that we have yet to annotate them. So let's do that now. Up at the top here, we can click Annotate Images to be dropped into the annotation flow. At the beginning, we actually don't have any objects that we can annotate, so we need to add one. Now in this case, we only want to detect one type of object, and that's a hand, and we want to have 5 key points. A thumb, an index finger, a middle finger, a ring finger, and a pinky. We're just going to be training a pose estimation model in this case, so we don't need bounding boxes. But if you were doing another model type like object detection, you could click this here. So we've saved that, and now we're able to annotate hand objects in an image. By selecting the hand, and then selecting the key point that we want to annotate, we can place it on the image. Now, you can either use this left-hand navigation here to switch between objects, or you can use the keyboard shortcuts that we provided in the keyboard shortcut bar. When you're done annotating the image, save it by pressing E. Now, just like this, we'll go through and label all of our images. One of the things that's really important about seed image collections is to try to get as much diversity into your dataset as possible. Because we're going to be using these images to generate thousands more, the more diversity that you can get in your seed images, the better your model is going to perform. In this case, I'm trying to make sure that my seed images have a wide variety of ages, genders, races, any sort of diversity that we think might happen in real-world use. If for some reason we find an image that we don't like, we can actually skip it, and it won't be included when we generate our data set. Now, I'm going to go ahead here and fast forward through all the rest of these annotations. Alright, now that all of our images are annotated, it's time to generate a data set. In order to create a data set, we've got to fill out the following form. First, we'll give our data set a name. We'll make sure that we're using the hand seed collection that we just created. And in this case, we need to pick the number of images that we want to generate. Now we've uploaded 15 seed images. We've labeled 14 of them. And at Fritz, we recommend about 100 images per seed image that you have, which is why the default here is going to be 1400. But in most cases, 1400 images won't be enough to train your actual model. And so I'm going to increase this to 5000. Now we can create a data set. After creating a job, we'll be taken to the dataset job page. Here you can see some details about the configuration of your job, how many images we're generating, and the status. You'll get notified by email when the dataset's ready to use. As we refresh the page here, we can see the job progress. So far, we've generated 300 of the 5,000 images. Typically, it takes somewhere between 15 and 20 minutes to generate these 5,000 images. Once our dataset is done generating, we'll see a preview at the bottom of the screen here. This illustrates the concept of synthetic data generation. For each of our seed images, we've pasted it onto a truly random background. This can result in some pretty funny looking images, but believe me, it's more than enough to train machine learning models with. Also, note that each of these seed images has random augmentations applied to it. So in some cases, we drop out parts of the image, we add some noise, and all of this is to increase the variability in the dataset and improve the quality of the model. Now that we've got a dataset generated, let's go ahead and train a model from it. On the model training form, we'll have to give this job a name. We want to make sure that we're training a pose estimation model because that's the task we're trying to solve for. And now we can choose a model variant. We've created 3 separate model variants to handle different use cases. Small models are very tiny and they don't increase the size of your app very much. Fast models are meant to be used in real time, and accurate models give you the absolute highest performance if speed isn't important. In this case, we want to use our app in real time, so I'm going to go ahead and create a fast model. Next, I have to give my model a name, let's call it hand pose, and then set a training time budget. We recommend 5 hours to train this model, but if your model is done training early, we'll stop it for you and you won't be charged for the remaining time. At the bottom here, there are a few different optional fields that you can set. If you wanted to start training a model from an existing version that you already have in Fritz, you could select it here. If you want to save checkpoints as new versions of existing models to keep everything organized in the same place, you could link those up at the bottom. Because we're training our first model, we don't actually have anything to set here. And one final thing to note here is that in every training job, we give you full cross-platform support. So when your model's done training, we'll create Core ML and TensorFlow Lite versions of that model so that it can be used on iOS and Android interchangeably. So let's go ahead and start our model. After you've started your model training job, you'll be taken to the job details page. Here you can see all of the different parameters that you use to set up your training job along with the job status. As always, you'll get an email when your model's ready to use. Here's the model I trained earlier. As you can see, the training job was successful, and even though I selected a 5-hour training budget, it was done in only about 20 minutes. At the bottom here, we've placed the output checkpoints for all of your models on each different platform. If we click on one of these checkpoints, we're taken to the model details page. In the left-hand panel, we see some information about our model, the name, description, any tags or metadata that we've added, and a number of different action items that we can take. On the right side, we see a table of all of the different versions that we've created of this particular model. Currently, version number 4 is active, meaning it's the one that's being sent down to all of our users. At any given time, you can download and integrate any of these models into your mobile app. For example, if I wanted to get model number 4, I can download the link here, and by clicking SDK instructions, I get model-specific code snippets that I can copy-paste directly into my app. If you need some help getting started, you can head over to our GitHub page where you'll find examples for both iOS and Android. I've already integrated this model into our pose estimation demo and hooked it up to our dataset collection system. The dataset collection system allows developers to capture images, model predictions, and user-generated annotations directly from app use in the real world. This data is critical for measuring model performance in production and gathering valuable data for model retraining. Let's see how it works. By building the app, we can see how the model performs in real time. Each key point detection is drawn on the screen and key points are connected with a line. As you can see, it's definitely tracking my hand, but it's not quite perfect. Let's go ahead and gather some data to improve our model over time. So back over in the Fritz web app, we're going to create a new image collection. Now before, we chose a seed image collection because we were going to be generating synthetic data, but this time around, we are going to create a model-based image collection. Now, model-based image collections are tied directly to models that you've trained using Fritz AI. They can be used to collect and store annotated images directly from usage out in the real world. And so this is exactly what we want to do in our case. We want to collect data from cases where our model's not performing well on the phone, and then we want to annotate them in the web app here and then use that to train a new version of the model. So I'm going to name this hands in real life, and now we have to tie it specifically to a model. Great. So again, we end up with a blank image collection because we don't have any images yet. And so let's go back over to the mobile app and just collect a few shots. With our app open, let's find some cases where the model's not performing quite well. Here, we can snap a few photos, accept them, and the Fritz SDK will do the rest. As we refresh our image collection, we can see that the 4 images that we've taken have been uploaded to Fritz. By clicking on one of these images, we can see the annotations that the model's recorded. Clearly, it's not doing well. So let's fix these up. At any time, we can flip back and forth between the user and the model to see what the differences are. You probably need more than just 4 images to retrain your model, but with the Fritz dataset collection system, it's easy to gather the high quality data that you require. And once you're done, all we have to do is generate a new dataset so that we can use it for retraining. In this case, we can't specify the number of images to generate because we're just going to create a dataset with all of the images that we collected. And there you go. You can see these images here. Just like before, we can download them. And of course, what we really want to do here is train a new model. So this time, we'll call our model job hands synthetic plus real. We still want to train a pose estimation model, but now we're going to select both the hands and the synthetic hands data sets to train our model with. So we can choose multiple data sets here. Now it's really important to make sure that both all the data sets that you choose have the exact same annotation config, which they do in this case, and we still want to train a fast model. Train for 5 hours again. It probably won't take that long, but this time around we actually want to use the previously trained model as a starting off point for this one. So we select the hand pose model that we just trained. It's automatically going to choose the most recent version here, which is number 3, and then we want to make sure that the new versions of these models are attached to the existing ones. So we're going to select the existing version of the hand model that we've created as the place to store checkpoints from this new job. Again, just verify this is all correct and kick off a new training job. And when this is done, just like before, the output checkpoints will appear for us in a card at the bottom here. So as we can see, when the model's finished training, Fritz has automatically uploaded a new version right here in the table. That's version number 4. And to test that out on our device, all we have to do is change the active version to this most recent one. Update that. Now we can see the active version has changed, and we don't even have to rebuild Xcode. All we have to do is click our app. It automatically downloads the new model, and we can see that from that real data, now things are performing much, much better. It's much smoother, much more accurate for these positions. And that's it. That's everything I wanted to show you today. In just a few hours, you can go from an idea to a working cross-platform prototype that you can test further, retrain, and improve on, all within the Fritz AI ecosystem. Just to recap, we use synthetic data generation to programmatically create a dataset with thousands of images in just a few minutes. We then use that dataset to train an initial model optimized for real-time use on iOS and Android. We then tested that model on a target device and set up a data collection pipeline to gather ground truth data from the real world. We then retrained the model with this new data and noted the performance improvements and issues that still needed to be resolved. So where do you go from here? Machine learning is about constant iteration. The workflow that we went through today can be repeated over and over as you discover new edge cases and areas for improvement. We've tried to make the Fritz AI platform as easy to use as possible, and we sincerely hope that it enables you to finally build that ML feature that you've been dreaming of. As you move forward with your projects, we've included some resources below that you can use throughout your journey. Thanks for sticking through to the end. We'd love to hear from you, so if you have a project, an idea, a feature request, or if you'd like to see more of the product in action, don't hesitate to reach out via our Help Center. The link for that is in the description of the video below. Take care and happy building!